Balancing in chemical equations. So the principle that lies at the heart of balancing is that atoms are conserved. So atoms cannot be created or destroyed. What you start with is what you end up with. So if you start with 5 atoms of copper, you have to end up with 5 atoms of copper. Same number of each type of atom. Okay, and it can be helpful to think of Lego blocks. If you start with 5 2x2 red bricks, you have to end up with 5 2x2 red bricks. They don't magically transform into 2x4 bricks. You just can't change them around and make them what you want. Okay, so what you start with is what you end up with. All we're doing in a chemical reaction or a chemical equation was just rearranging the building blocks. You might wonder, well, how do you know what the reactants and products are? Well, those have been determined by experimental observation. And so people have, done a lot of experiments and figured out, okay, this is what we started with, and then we ended up with this. And so that's not something that you just make up as you go along. So when you're given like that I guess it's a sentence, isn't it? That's what they call it when it's words, sentence. When you get given that sentence describing the chemical reaction, they're telling you what the compounds are, the reactants and the products. And so you write down those formulas, and you can't just change the formulas to balance the equation, because those were determined experimentally, and we're not changing what actually happened by what we do in our equation. We're just trying to accurately describe what happened. So the formulas of the compounds must never be changed. It's really tempting sometimes. Resist. Do not change the formulas. So here's steps for writing and balancing equations. First of all, read the entire description and ask yourself, what are the reactants? What are the products? What are their states? And then write down the appropriate formulas. So here's an example. Hydrogen gas and oxygen gas combine to form liquid water. And this one, they're being nice, and they're actually giving us the formulas. So you're going to write down hydrogen gas and oxygen gas and liquid water. Okay, so I'm probably jumping ahead of myself, but that's okay. I'm going to do it anyway. So these are the reactants, and this is the product. So the reactants are on the left side of the arrow, the products are on the right side of the arrow. So this is like a skeleton equation, an unbalanced equation. We have to get the formulas in there first. And if they give you states, or if they ask for states, you should write those down. We do not always write them down, but if the question asks you to do it, you have to do it, or you'll lose points. So write the unbalanced equation that summarizes the information. That's what I did and what just got erased. Okay, so H2 gas plus O2 gas goes to water liquid. Then we're going to balance the equation by inspection. Balancing by inspection is basically a trial and error sort of method. There's no beautiful formula that I can give you, and two people may balance an equation in a different way, ending up with the same correct answer. A guideline is to start with the most complicated molecule. And so here with that unbalanced equation, H2 plus O2 goes to H2O, sorry. What you're going to do first is count the number of atoms of each element on each side of that arrow. So they've kind of, this can be a good idea, draw a line at the arrow, and that's kind of like the middle of the teeter-totter, and you're trying to balance it. Okay, so you have the same number of hydrogens on the left as you do on the right, the same number of oxygens on the left as you do on the right. And so first of all, you have to just look at it and figure out, well, what do I have? And we see that we've got 2 hydrogens and 2 oxygens on the left. we've got 2 hydrogens and 1 oxygen on the right. Well, that's not balanced. So we need more oxygens. So if we put, so we had 2 oxygens on the left and only 1, originally only 1 on the right. If we put another water molecule in there, now we've got 2 oxygens, and that balances the 2 over here. But now we created another problem. The hydrogens were okay before. We had 2 and 2, but now we've got 2 over here and 4 over there. So the solution to that is to add another hydrogen on this side. And now we end up with 4 hydrogens on each side and 2 oxygens on each side, and it's balanced. And so then we're going to rewrite this equation and combine like terms and say there's 2 H2s plus O2 goes to 2 H2O. And the last step is important. Always check and make sure that you've got it okay. Check to see that the coefficients used are the smallest integers. Occasionally, you go off kind of on a strange path, and you could end up with 4H2 plus 2O2 gives 4H2O. That is balanced, but it's not the lowest ratio. And so the best equation is with the lowest ratio. See, I did it again. It's like I can see into the future. So this is not the best because this is not the lowest ratio. If you draw those out as ratios, 4 to 2 to 2, that can be reduced to 2 to 1. I'm sorry, that's... Yeah, let's just make messes. That was a 4. So in our balanced chemical equation, we want the lowest ratio. And sometimes in the multiple choice questions on an exam, they'll give you 2 equations that are balanced, and one of them is not the lowest. And so sometimes people fall for that because, well, it's balanced, but we want the one with the lowest ratio of coefficients. So that's the preferred one. So let's do some of these.
But in order to balance it, each one of the elements must have a coefficient next to it, or you can't. If you go like one of them, and there's a 2 and a 4, and then you can't simplify it, can you?
Well, it's the same thing with the ones. It's implied that if you have the formula in there, you have one of them. So if there's no coefficient, we understand that to mean that there's 1. So they all do have coefficients, but we don't write the ones.
But you wouldn't reduce it.
But you can't reduce
2,
it if
4,
there's a
and
1.
That's what I'm saying.
Right.
You have to have a 2, 4, and 4, or a 2,
Yeah.
2, 2, okay.
So let's do this one. So one way to approach this, and when you're first starting out, you're going to have to write a lot of stuff down to get all of this straight. And then once you start to see how it works, you can sometimes just go to balancing it without writing stuff down. But for now, we're going to write stuff down. So draw a line like this and separate the products from the reactants. And then look at what elements do I have there. Well, I have 2 elements. I have iron and I have oxygen. And so first I'm just going to take an inventory and figure out how many of each of these do I have. So over here, FeO, I've got 1 iron and 1 oxygen. Over here, I've got no irons and I've got 2 oxygens. So I've got a total of 3 oxygens on the left side and 1 iron. And over here on the other side, I've got 2 irons and 3 oxygens. And so then you ask yourself, well, is this balanced? 1 plus 0 equals 1. Does that equal 2? No. I need more iron on the left side. So I can do that by putting a number, a coefficient, in front of the FeO. That changes both of these guys. Because now I have 2 irons and 2 oxygens. Do you see that? So now my total, 2 plus 0, I've got a total of 2 iron atoms on the left side, and I've got 2 irons on the right side. So that one's good now. Now let's look at the oxygens. I've got 2 plus 2, that's 4. But on the right side, I've got 3. So I need to put more oxygens in on the right side. The only way I can do that is by putting another molecule over there. I can't change the subscript and make it a 4. It'd be really easy. It'd work out real fast that way. So I'm going to have to put 2 of these. Oops. 2. That changes everything underneath it. So now I've got 4 irons and 6 oxygens, and this is not balanced anymore. Sometimes that happens. You screw up something that you had fixed before. Well, what do? Well, let's go fix the irons. So I've got 4 on the right, I need 4 on the left. So I'm going to have to change this to a 4. And that's going to change this to a 4 and this to a 4. So sometimes we feel like we're kind of going in circles. As long as you only go in the circle a couple of times, you're okay. If you find yourself going around and around and around, start over. So that changed the number of irons, and so now we've got 4 here. And it changed the number of oxygens. Now we've got 6. Oh, look. It worked out now, didn't it? I've got 6 oxygens on the left, 6 on the right, 4 irons on the left, 4 irons on the right. And so that's our balanced equation. 4 FeO plus O2 gives 2 Fe2O3. Those are the lowest ratios, 4 to 1 to 2. That can't be reduced because those coefficients are not all divisible by a number. They don't have a common factor other than 1. Dividing by 1 doesn't change anything. Any questions?
You couldn't have balanced the equation by just adding an iron oxide on the reactant side?
Adding an FeO?
Yeah, because then that would give you two irons on, or FeO, sorry, 2 Fe's on both sides, and then 3 oxygen.
The problem is, with the original equation, is that I had 1 iron here and 2 there. The oxygens were okay to start out with. I had oxygen, 1 oxygen, and 2 was 3, and here was 3. The problem is I can't add any irons without adding oxygen.
Gotcha.
If we could just put a 2 in there, but we can't do that.
Got the subscripts.
Yeah, so you can't change the subscripts.
Okay.
This is one of those things, it just requires some practice. Okay? It just does. So hopefully you wrote that down. The way the test bank asks these questions sometimes is it says, determine the sum of the coefficients. Okay, so what were the coefficients? Well, this was a 4, right? And this was a 2. What's the sum of the coefficients? 7. Okay, they should have put 6 in there because that's the common wrong answer. There's a 1 here. We didn't write the 1. Okay? I don't ask the question this way very often, but occasionally I do. So there's a 4 and a 1 and a 2. You add those up, you get 7. Let's do another one. Here's a multiple choice. We're going to run through it first without looking at the multiple choice thing. So they're saying which of the following correctly balances the chemical equation given below? There may be more than one correct balanced equation. If a balanced equation is incorrect, explain what is incorrect about it. But let's just balance this first. So I'm going to draw a line here. to separate products and reactants. And I've got calcium, and I've got oxygen, and I've got carbon. And so I'm going to just tally them up and figure out what I've got to work with here. In CaO, I have 1 calcium, and I have 1 oxygen, and I have no carbons. Over here, this carbon, I have no calciums, no oxygens, and 1 carbon. CaC2, 1 calcium, no oxygens, 2 carbons. And then CO2, I've got no calciums, I've got 2 oxygens, and 1 carbon. So some of you will need to do this, and some of you won't. So calcium, the calcium is balanced already. There's 1 of each. But the oxygen's not balanced, and the carbon's not balanced. And so this is where it says to start with the more complicated product or reactant to balance. So another way to say that is if you have an element that's all by itself, like your carbon is all by itself, leave that one for last. Don't balance that one first. Leave that for the last. Because when it comes down to the end, you could adjust the C without messing up anything else. So we're going to look at the other ones first. The calcium's already okay, so we'll leave that alone. We're going to skip carbon, and we're going to look at the oxygens and see if we can figure out how to do the oxygens. So with the oxygens, we got 2 on the right, 1 on the left. We need to add 1 to the left side. We do that by putting a 2 in front of the compound that has oxygen in it. So now we got 2 calciums. So that changes what we have here. I'm going to erase this time so it doesn't get so crowded. So now I have 2 calciums and 2 oxygens. So that fixed my oxygen issue, but it caused a problem with the calcium. So now I have to go over here and put a 2 there, and that's going to change the calciums and the carbons. Now I have 2 calciums and 4 carbons. That didn't mess up the oxygens though. So now I've got calcium and oxygen straight. Now I can go fix the carbons. I've got 4 on the right side and only 1 on the left. If I put a 4 in here, then I'll get 4 carbons, right?
Isn't there 5?
5 what?
There's 5 carbons.
Oh, you're right. Thank you. I can't add today. I forgot about this guy over here. There's 5. Okay, so we can fix that. Whoops. Get the right tool here. Got the eraser. So I have 5 on the left, not 4. That's why the checking comes in. So I need a 5 here. Now I'm okay. And then go through and check it without looking at your scribbling. So here I've got 2 calciums, and over here I've got 2 calciums. Here I've got 2 of those oxygens, and over here I've got 2 oxygens. I've got 5 carbons here, and I've got 4 there and 1 over there. So a total of 5. So that's our balanced equation. 2 plus 5 plus goes to 2 and 1. So then here are the choices. I'm going to write those coefficients back in here. This was a 2 and a 5 and a 2. So doing this on an exam, you can do what I did, which was to balance it first and then go look at the choices. Or you can do a different approach, is to look at the choices, eliminate ones that are obviously wrong, and then look at what's left. So here, this one matches up with what we came up with, right? Number 1 is not balanced, is it? Well, actually it's balanced, but what did they do? They changed the formula. You see this? You can't do that. So that one's bad. What about number 3?
They didn't try to fight it.
Well, you can do that, but it's not ideal. We would prefer to have whole number coefficients. But is it balanced? It is. It's the same ratio, it's just that they're not whole numbers. Well, yes, you couldn't have half of a carbon dioxide molecule. But if you had a dozen, you could have half a dozen. And we never have an experiment where you just have individuals. So, and number 4. So this one's balanced, it's just not the best one. And what about 4? It's not the smallest. That's everything's multiplied by 2. So these last 3 are all balanced, but number 3, I'm sorry, number 2. Number 2 is the best one.
It's Monday.
It is Monday. It is very, very definitely Monday.